Welcome back to Baga Coding. Today we'll be working on another LeetCode question, k closest points to origin. So for this question, we are giving an array of points where each point have x and y, and we had to return the k closest points to origin. So how do we find the distance of each point to the origin? We had to calculate the square root of the sum of square x plus square y, and that would be our distance of each point to origin. So let's look at example here. Here we have 2 points, and we had to return 1 point that's closest to the origin, and the answer will be the second point. Because for the first point, the distance of first point to the origin is square root of 10. We get the square root of 10 by having 1 times 1, which is 1, plus 3 times 3, which is 9. And then the square root of 1 plus 9, which is square root of 10, will be our distance to the origin. And for the second point, we have negative 2 times negative 2, which is 4. And then 2 times 2 is 4. So 4 plus 4 is 8. And the square root of 8 will be the distance of the second point to the origin. So in comparison of these two, apparently square root of 8 is much closer to the origin because it's smaller. So let's start coding. First, we had to create a result array of k length, and each array inside the result array will have length of 2, which will be x and y. So we create result array of k length and 2. Then, in order to find the k closest point to the origin, we will have to sort each point in the points array in order from least to largest, depending on the sum of square of x and square of y. And we can use a main heap queue, priority queue, to do that. So we create a priority queue of PQ, new priority queue. So first we create a priority queue, and then we set a comparator for this priority queue. We had to calculate the sum of square x and square y and then sort them in ascending order. So we will have to use a lambda function for this. Return a0 times a0 plus a1 times a1 minus b0 times b0 plus b1 times b1. And then we have to, for each point inside the points array, we had to insert it into the priority queue. pq.offer p, and then the priority queue will sort each point in ascending order depending on the sum of square of x and square of y. And then after they are sorted in ascending order, we can pull out the point from the priority queue and add it to the result array. So while star is less than k, pq. So until there are k points in the result array, we pull out the point from the priority queue until the result array have k point, because the question asks us to find the k closest points, k amount of closest points that's closest to the origin. And then we return the result array. Cross my finger. Oh, we forgot to increment the star index, because every time we insert a point to the result, we had to increment the star index. Yes, so the time complexity for this solution will be n log k. So I will see you guys next time. Bye.